Hello students, I am Shri Kumar, working as lecturer in Department of Pharmacy, Government Polytechnic Education Society, Ottawa, District Palwal, Haryana. It is lecture number 3 based on IUPAC Nomenclature of Organic Compounds, General Rules. In Chapter 2, Classification and Nomenclature of Organic Compounds, mentioned in subject Pharmaceutical Chemistry, second, taught in Diploma in Pharmacy, second year. Learning objective of this lecture session is to make the students aware about general rules followed for IUPAC nomenclature of organic compounds. In the previous lecture, we have discussed about the two types of the nomenclature system of the organic compounds. One is the tribal system or the common names of the organic compound, and second one was the derived name for the organic compounds. In this lecture session, we will discuss about the IUPAC nomenclature of organic compounds. International Union of Pure and Applied Chemistry, abbreviated as IUPAC, devised a novel method of the nomenclature of organic compounds, which is adopted globally as a standard method for the nomenclature of the organic compounds. In the literature of the organic chemistry, the IUPAC nomenclature system has been adopted globally, or we can say as a standard method for the nomenclature of the organic compounds. The IUPAC nomenclature of the organic compounds has been accepted. In most of the literature, the nomenclature given for the organic compounds is based on IUPAC system of nomenclature. The main part of this system includes the root word, primary prefix, secondary prefix, primary suffix, and the secondary suffix. The first part, that is the root word. The root word represents the length of the carbon chain decided by the longest chain rule. Actually, the root words gives us the information about the length of the carbon chain. And what is the longest chain rule? We will discuss about it in detail in the upcoming slides. The second part is the primary suffix. The primary suffix represents the saturation or the unsaturation in the organic compound, whether the compound is fully saturated or whether the compound is unsaturated, means that is a compound has a multiple bonds. For example, the compound may have the single bonds, the compounds may have the double bonds, or the compound may have the triple bonds, or the compounds may have the single, double and the triple bond simultaneously in a compound. The third is the secondary suffix. The secondary suffix represents a main functional group in the organic compounds, which is responsible for the chemical reactivity and the physical properties of the organic compounds. Another one is the primary prefix. The primary prefix tells about, or primary prefix gives us the information regarding the nature of the organic compounds, either the given organic compounds or the compound for which the nomenclature is given is either cyclic, that is represented by the cyclo, bicyclic, spiral, and the fused rings, for example benzo, indolo, pyrrolo, etc. The another one is the secondary prefix. The secondary prefix represents the substitution or the extent of the branching in the organic compounds. Basically, and there is a dilemma, or however, that's one is there seems to be a lot of the difficulty in deciding that's one is the what is the secondary prefix and what is the secondary suffix, because a functional group, if a compound has the two types of the functional groups, so then it becomes very difficult whether which one functional group should be treated as the secondary suffix and the which functional group should be treated as a secondary prefix, or we can say that's one is the which functional group should be treated as the main functional group and the which functional group should be treated as a substituents. It is basically decided by the priority order of the functional groups or the substituents. On the basis of this priority group, we determine that in between these two functional groups, which one should be treated as the secondary suffix and which one should be treated as a secondary prefix. That's it. Or we can say, in the another words, we can say that is which one should be treated as the main functional group and the which one should be treated as the substituents or the extent of the branching in the organic compounds. Now we will discuss about the general rules followed for the IUPAC nomenclature of the organic compounds. The first rule is about the longest carbon chain or the rule of the longest chain. The longest carbon chain, the root word, having the maximum number of the substituents and the maximum number of the function group is selected. That's mean first of all we will have to select a carbon chain which will cover the maximum number of the substituents and the maximum number of the functional groups, and for the parity order for the numbering of the carbon chain is the function group. That is the first of all we will have to, for the numbering purpose, first of all we will have to consider the function group, then the multiple bond. In the multiple bond we will have to give the parity first to the second double bonds, and then to the triple bond, and then the substituents. And while selecting the carbon chain is numbered in such a way that the carbon atom nearest to the function group or the unsaturated double bond to the parity order mentioned in the group number 1. That's one is we will have to keep the two things in the mind. First of all, we will have to start the numbering from the carbon atom which is at the nearest position to the functional group. But we will have to also keep one thing in the mind, that the numbering should be done in such a way that the carbon chain the selected should cover the maximum number of the substituents and the maximum number of the function group. Say one example here. In this example, the longest chain is the 8 rows, and this compound is a 4-ethyl to 6-methyl of 2 in 2 all. Here you will see that's one is the function group in this compound. The function group is also here. This one is a function group. The unsaturation is there, and the branching is also here. These are the three things are there. Now first, as per the rule, the first of all the select the function group, and here the function group is this one, the OH, that is the alcohol, and which one is symbolized by OL. Okay. Here the carbon number second, that is this carbon. Okay. This carbon is adjacent to this one, and but we cannot select this carbon for the numbering, or we can say that's why we cannot start the numbering of the carbon chain from this carbon atom, because if we will start the carbon chain from this carbon atom, then this will be the 1 2 3 4 5, it is only the 5 membered, and the another chain this is the 7 membered. Okay, and this is the 6 membered also. So that's why we will have to select the another carbon atom for the position for the numbering of the carbon chain. And for this purpose, if you will select the carbon this carbon, then the carbon chain will be the 8 membered, like this one. Okay, so that's why you will have to select the carbon atom from here. Then you will select that one is this is the 1 2 3 4 5, and it is a 8 membered carbon chain. So that's why the root word will be the oct. Okay. Now come to the primary suffix. The primary suffix describes whether the saturation or the unsaturation in the compound. Here that's when the unsaturation is described by, or unsaturation is depicted by the presence of the one single bond, that one double bond that is present at the second carbon atom. So that's why the primary suffix is the 2 in. Okay. Now come to the secondary suffix. The secondary suffix describes the function group in the carbon chain, and here the function group is the all. So that's why the 2 all is the secondary suffix. Now come to the primary prefix or the secondary prefix. In the primary prefix, that tells about the nature of the organic compound, whether this one is a cyclo, this one is pyro, this one is a fused extra. But here that's the no, it is not the cyclic compound, it is not the spiral compound, it is not the bicycle compound, and it is the fused ring compound. It is a simple chain compound. It has a simple carbon skeleton. So that's why the primary prefix, which may also be used as a primary prefix in this compound, but however that's why I am using the secondary prefix, because in the previous slide I have told that's why the secondary prefix tells about the extent or the substituents. Here that's one is here the no substitution is there, but there is a extent of the branching is there, and the branching is represented as the at the carbon number 4 by the ethyl, and at the carbon number 6 by the methyl. And this branching may be represented either by the ascending order of the position of the carbon atom, or by the alphabetically, and if you will apply both the things, then this will come as the 4-ethyl and the 6-methyl, that will be used as the secondary prefix. So that's why the name of for this compound is a 4-ethyl 6-methyl of 2 in 2-ol. If the longest chain contains more than one similar alkyl groups or the substituents, then their positions are mentioned separated by comma before the numerical prefix like di, tri, tetra that represents the number of the similar alkyl group attached. See example here. The one example, look at the first example, this one. In this compound, the longest chain is in this compound, the longest chain is this one. See here. So, and in this chain, the 2 methyl groups are attached at the second and the fourth position. Since the longest chain is the 7-member, so the root word will be the hept. It is an alkane, so N will be the primary suffix, because the primary suffix tells about the whether the compound is a saturated or the unsaturated, and in the prefix there are the 2 methyl groups and which are present at the 2 and second and the fourth position. So that's why this will 2,4-dimethyl. So the name of this compound will be the 2,4-dimethyl heptane. Now see here the another example. As per the first rule, the C, whether the compound has a functional group or the substitution or the unsaturation, then there is a functional group, that is the OH, and this carbon is the adjacent to the functional group. So that's why we will have to start the numbering from here in such a way that the longest chain cover the maximum number of the functional group and the maximum number of the unsaturation and the maximum number of the substituents. So that's why if we will select the chain, then the longest chain is the 10 membered, this one. Okay, so that's why the root word will be the deck. See here, now the deck will be the root word. Okay, it will be the root word. Now come to the primary suffix. The primary suffix represents about the carbon is that the chain is a saturated or the unsaturated. Here the 2 double bonds are there, one at the first position and another one as the 5th position. So that's why this is the 1,5-diene. This will be the primary suffix. Now come to the secondary suffix. The secondary suffix describes about the function group. The function group is the ol, that is represented by the ol, and it is present at the first carbon atom. So that's why it is the first ol. Okay, so and it is the secondary suffix. Now come to the prefix. In the prefix you will see here that is there is a no cyclic compound, this is a no benzofusel, or this one is a no spiro or no bicyclo. It has the extent of the branching here, and the extent of the branching is represented by the 2 ethyl groups at the 6th position and the 8th position. So that's why 6,8-dimethyl is used as the prefix only. That is, there is no primary or the secondary prefix, because there is only the one prefix. So that's why the name of this compound is the name of this compound is a 6,8-diethyl DAC 1,5-diene 1-ol. Now come to the next rule. If the carbon chain selected has 2 different alkyl groups, then these alkyl groups are mentioned according to the alphabetical order. For the alphabetical order, di, tri, tetra, etc., numerical prefixes are not considered. That's one is that we will have to not consider the number of similar alkyl groups, but we will have to select the alkyl groups as per their, we will have to arrange the alkyl groups as per their alphabetical order. See the examples here. And the first example is this one. The first example is this. Now see this example here. So that's why if you will select in this compound, that is you will see that's what is the functional group. That the functional group is the COI, that is the acids, and which one is at the position number 1 in the priority order. So that's why we will have to start the numbering from here. So because it has a, because this functional group has also the carbon, so that's why the carbon atom of this functional group becomes a terminal carbon atom. So that's why we will have to start the numbering from this carbon atom. That's one is the carbon atom of the carboxylic groups in such a way that the longest chain will again cover the maximum number of the carbon atoms, the maximum number of the unsaturation, the maximum number of the functional group, and the maximum number of the substituents. So if you will select the chain, then the longest chain is the 7 membered. Then so that's why what will be the root word will be the HAP. So that's why the root word will be HAP. Now come to the unsaturation. So that's why if you will see the unsaturation, that is this one is the, this is the root word. HAP is the root word. Now come to the primary prefix, primary suffix. In the primary suffix, as per in the previous slides, that's when we have discussed the primary primary suffix represents the saturation or the unsaturation. This compound is unsaturated because at the third position there is the one double bond. So that's why this is the 3 in here, is the 3 in is the primary suffix. Now come to the secondary suffix. Secondary suffix, again the secondary suffix represents the functional group, and here the functional group is the carboxylic acids, which one is symbolized by the oic acid. So that's why at the first position, that is this one is the oic acid. So that's why the oic acid is the secondary suffix. Now come to the prefix. In this prefix we have again that's one we are observing again, that is here, that's one is the alkyl groups are represented as the extent of the branching. So that's why there are 3 alkyl groups, 2 ethyl groups at the 2 and 3rd position, and the 1 methyl group at the 6th position. But since you will see here that so ethyl groups comes first and the methyl groups comes later, as we will arrange them in the alphabetical order, and we will not consider that the number of the alkyl groups into the consideration. So that's why this will become the 2,3-diethyl, because the ethyl comes at the first and 6 methyl comes at the later position. So that's why the name of this compound is a 2,3-diethyl 6-methyl hept 3-in-1 oic acid. Now see the another example. In the another example again, so you will see that's one is the first of all see that's one is the functional group here. So that's why you will see that so there are the 2 functional groups, one is the acid and second one is the alcohol. But among the but between these two these 2 functional groups, at the priority order the carboxylic acids comes, and since the carboxylic acid contains a 1 carbon atom, so that's why we will have to start the numbering from this carbon atom. So that's why, and then we will have to select the longest chain. If we will select the longest chain, then this is the longest chain. So that's why the root word will be HAP. So that's why the root word will be HAP. So that it is the root word. And now come to one thing. So that's why primary suffix again, the primary suffix tells about the saturation, the unsaturation. At the 4th position there is a 1 double bond. So that's the primary the 4 in will be, this will be the primary suffix. And since among these 2, OH and the OH and the COH, that's when at the priority order COOH comes first and the OH comes later. So that's why we will have to consider the OH as a substituent, and whereas the COOH as a functional group. So that's why COH will become the secondary suffix. So one oic acid is the secondary suffix. Now come to the primary prefix. The primary prefix tells about, your primary prefix represents the extent of the branching or the substitution. So that's the extent of the branching. You will say here, that is there is the isopropyl group is added. So that's why this is a 2-propan-2-yl at the 3rd position, and at the 6th position there are the 2 methyl groups. If you will arrange that methyl and the propan-2-yl groups, then the methyl group comes first. So that's why the 6,6-dimethyl 3-propan-2-yl, that is this is the primary prefix. And since the secondary suffix tells about the that one is this tells about the substitution, and the OH groups comes later in the priority order, so that's why the hydroxy group will become the secondary prefix. So that's why the name of this compound is the 5-hydroxy 6,6 dimethyl 3 propan 2 allyl hapt 4 in 1 oic acid. Now come to the another rule. If the two alkyl groups are present at same distance from either corner of the carbon chain, then numbering of the chain is done according to the alphabetical order of the alkyl groups. Now see the example. In this example, you will see that is there is a no functional group is here, but there is a two double bonds. One is this and another one is this. So that's why the longest chain rule should as per the longest chain rule, the carbon chain should be selected in such a way that it will cover these two double bonds and should be the maximum and should contain the maximum number of the carbon atoms. So that's why if we will select the longest chain, then this will come with the longest chain. This is the 8 membered, so that's why the root word will be octa. That is, this will be the root word. Now come to primary suffix. But see here, that is at the terminal position, that is there are the two methyl groups, one as here and one as here. So that's why if we will consider that if from which terminal we should start numbering, and you will see that if you will start from this end, you will see that is at the second number there will be the unsaturation, and from this carbon and from this terminal at the second position there is also the unsaturation. But if you will see from the from this position at the 4 there is the ethyl group is attached, and from this terminal at the 4th carbon atom, that is there is the methyl group is attached. But if you will arrange ethyl and the methyl in alphabetical order, then the ethyl will come first. So that's why we should have we should do the numbering from that carbon atom or that terminus from where these ethyl groups come first. So that's why we have performed numbering from these terminus. That is why we have started the numbering from this terminus. While performing the numbering from this terminus, okay, so the longest chain is the 8 membered, so that's why the root word is the 8, and the unsaturation is present at the second and the 6th carbon atom, so that's why the primary suffix will be the 2,6-dine. Now come to the prefix. As per that is there are the two substitutions, or that is there are the two extent of the branching, as one is the methyl group and another one is as a ethyl group. Since the ethyl comes first in the alphabetical order and the methyl comes later, so that's why it will become the 4-ethyl 5-methyl. So name of this compound is the 2,4-ethyl 5-methyl oct 2,6-dine. Now come to next one. The unsaturation, double or the triple bond in the chain are represented by the primary suffix, and the functional group in the carbon chain are represented by the secondary suffix, as we have discussed earlier. But here that's not what we want to discuss. That is the terminal E of the primary suffix is generally removed before adding the secondary suffix if the secondary suffix begins with the vowels A, E, I, O, U. Okay, now see that is this examples, or we can say that's one thing. So we can say that is see the two examples here. In this first example, that one is the what is a functional group? Functional group is the OH. So that's why this is the functional. So that's why we will have to start the numbering from the carbon atom, which one is the adjacent to the OH, and there is also the one unsaturated group is here, or one double bond group is here. So that's why as per the longest chain rule, we will have to select a carbon chain which we will which we will cover the maximum number of the carbon and this double bond. So that's why while applying the longest chain rule, the longest chain will be like this one, and which one is a 5-membered longest chain. If the 5-membered longest chain, then the root word will be the pant. Okay. Now come to the primary suffix. The primary suffix represents the saturation or the unsaturation in the compound. This compound is unsaturated, and the unsaturation is represented by the one double bond at the 3rd position. So that's why 3 in. So that is 3 in is the primary suffix. Now come to the secondary suffix. The secondary suffix is represented by the functional group, and the secondary suffix, and in this compound the functional group is the OH, so that's why the all will be the secondary suffix. So that but and it which one is present at the first position. But here in this rule, that's what we want to say. We want to say that's the this is the here if you will see, that's one is the primary prefix is the primary suffix is the in, and that's an e, or e, this e has been removed while adding the primary or secondary suffix. Now come to the prefix at the second position, that is an ethyl group is added, so that's why 2 ethyl pent 3 in 1 all. Now come to the next example. In the next example you will see that's a functional group is the COOH, that is a carboxylic acid or the oic acid. So that's why we will have to start the numbering from this carbon atom, since this carbon atom is included or is associated with the functional group. So that's why this carbon atom will become the terminus carbon atom, and we will have to consider this in numbering, or we will have to start the numbering from here. Now we will have to perform the numbering in such a way that will cover the maximum number of the unsaturation, maximum number of the substituents, and the maximum number of the functional group. See here, that's when the unsaturation is represented by the 1 double bond and the 1 triple bond. So that's why when you will select the longest chain is the 7 membered, and consider that is this UH, that is this is the 7 membered longest chain. So that's why what will be the root word? The root word will be the hept. Now come to the primary, and this is the root word hept. Now come to the primary suffix. The primary suffix is represented by the unsaturation, and in this compound the 1 double bond and the 1 triple bond is there. So that's why you will see that's at the second position, that is there is a 1 double bond, which one is represented by the 2 in, and at the fourth position, that is there is the 4, that there is a 4, and that is there is a 1 triple bond. So that's why the 2 in 4 in. But see here, that is this one is the in, and while adding the another so that's why another adding the another suffix here, so that's why we have removed this e from the in. The same case, if you will see, that's one is the if we will see the same case like here, so that's why we will see the same case here, that is this one is the ein, that is a triple bond is represented by this one, this suffix ein, and the e of ein has also been removed while adding the secondary suffix oic acid. So that's why this is the primary suffix 2 in 4 in, and whereas the oic acid, it is a functional group, so and the functional group is represented by the secondary suffix. The oic 1 oic acid is the secondary suffix. And now come to the prefix. So that's why here you will see that at the second position methyl group, at the sixth position methyl group, and at the sixth position there are the 2 dimethyl group. So that's why there are the 2 6. Okay, so that's why there are the 2 6 dimethyl hept 2 in 4 in 1 oic acid. Now come to the next rule. If the molecule contains more than one type of the functional group, the numbering of the parent chain is done such a way that the functional group of the higher priority order is placed at the lower number. That's when we will have to start the numbering in such a way that the functional group which comes at the higher priority at the higher position in the priority order should be assigned the lower number. And in brief, the priority order may be depicted as below. In the priority order, the first position is captured by the carboxylic acid functionality, that is a COOH. After the COH, that is this one is the SO3H sulfonic acid, then anhydride, then ester, then anhydride, then ester, and then halide, then the carboxy halide, and then this one is the amide, then this one is the nitrile, that is this one is the NC, and that is this one is the aldehyde, this is the keto, hydroxy, thiol, amine, ether, alkene, alkyne, halide, and the nitro. See, That one is the another example here. In this example, you will see that one is there is a one functional group, that is this one is the COOH. But in this COOH, that's when there is again that is this functional group contains the one carbon atom. So that's why we will have to start the numbering from this carbon atom. While we will number from this carbon atom, then the longest chain is the 8 membered. Okay, that is this is the longest chain from okay, so that's why root word will be the oct. At the third position, that is there is the triple bond, and at the first position one double bond is here. So that's why you will see that's an oct is the root word, 3-ine this is the primary suffix, and oic acid, that is this one is the secondary suffix. Okay, now come to the Chem. So that is in the prefix, that is you will see that is there are the one methyl group is at the second position, and the one methyl group is at the seventh position, that is this one is a dimethyl. So that's a, and the one ethyl group is at the sixth position. While arranging these alkyl groups, that is there are three alkyl groups, two methyl groups, one at the second position, one at the seventh position, and the third alkyl group is the ethyl group, which one is present at the sixth position. While assigning the numbering to the while assigning the nomenclature, or while assigning the nomenclature, that's when we will not consider that's one numbering assigned to the alkyl groups, but we will consider them we will consider the arrangement of the alkyl groups in the alphabetical order. So that's why, and while arranging the alphabetical order, ethyl and the methyl group in the alphabetical order, then the ethyl comes first. So that's why the name of this compound is a 6-ethyl 2,7 dimethyl oct 3-ine 1-oic acid. That is this one is the table, that's when we shows the priority order. That is in the table, that is you will see that's when a COH carboxy group, if the carbon group is using as a prefix, then the prefix is the carboxy and suffix is the oic acid. The another examples are in the second position there is a sulfonic acid comes, then the prefix sulfur comes for this, and the sulfonic acid is used as a suffix for the SO3H. Now come to the acid anhydride. Acid anhydride is usually used as the suffix only, and in the suffix that it is named as the oic anhydride. That's now that's alkoxycarbonyl, that is this one is the alkylate or alkoxycarbonyl, or that is you can say that this one is the ester. So that's why there are about the 18 examples, and this one is the priority order table. Now the next rule, if the main carbon chain has a two functional group, among them one have the terminal carbon atom, then it is not mandatory that carbon containing functional group should be counted for the numbering of the main carbon chain. But we will have to consider the numbering of the carbon chain. Main carbon chain must be done according to the priority order of the functional group. That's when if any compound has a two or the more functional group, and in among these functional groups, sometimes the functional group may have the carbon atom. For example, carboxylic group, carboxylic acid, cyano group, CN, isocyanide group, that's NC, or acid anhydride, that is the aldehyde, keto group, etc. There are a lot of the functionality that is which contains a carbon atom. But first of all, we will have to arrange, we will have to assign the numbering as per the priority group of the functional groups. See one example here. In this example, the given compound in this example, that you will see that is there are the three functional group. One is the SO3H, that is a sulfonic acid. The another one is the amino, and the another one is the CN, cyano group. Yeah, so that's why if you will see if you will see that is in the if you will see in the priority order table, then the SO3 just comes after the COH group. So that's why, and among these three functional groups, at the top position, that is there is a SO3H. that is sulfonic acid. So that's why we will have to start the numbering from this carbon atom, because this carbon atom is adjacent to the SO3H. So that's why SO3H group comes at the upper position in priority order of the functional group as compared to the CN group present. So the numbering of the carbon chain becomes from the carbon attached to SO3H. So that's why we will have to start the numbering from this carbon atom, and we will have to start the numbering from this carbon atom in such a way that it will cover the maximum number of the alkyl groups, maximum number of the functional group, and the maximum number of the unsaturation, like extra, as we have discussed already in the previous slides. So that's why if you will select the number of the longest chain, then this is the word, that is, this is a non-N, that is, it is a 9 member, that is, this one is a 1 2 3 4 5 6 7 8 9. As per the rule, that is, we have already said that as per the rule key, that is, in the cyano group, that is, you are observing that is one carbon atom is here in the cyano group, but we are not considering this carbon atom in numbering. So that's why, and here that's since as per the longest chain rule, the maximum number of the carbon chain, maximum number in the carbon chain are the 9. So that's why this is the root word is the non. Now come to the primary suffix. The primary suffix tells about the saturation or the unsaturation. This compound is unsaturation, and that is represented by the 1 triple bond and the 1 double bond. So that's why at the second position, that is, there is the ine, and at the fifth position, that is, there is the in. So that's a 5 in 2 ine. Okay, that these are the primary suffix. This say that's one is a 1 2 3 4 5, and at the first position, that is, there is sulfonic acid. The function group is and the secondary suffix is represented by the function group. So that's why 1 sulfonic acid is the secondary suffix. Now come to the prefix. In the prefix, that is, at the fourth position, there is the amino, and at the seventh position, that is, there is a cyano. If you will arrange these two functional groups as per the alphabetical order, then the amino comes first. So that's why this is the 4 amino 7 cyano. So the name of this compound is the 4 amino 7 cyano non 5 in 2 ine 1 sulfonic acid. Now see the another example of this. In this compound, that is, first of all, while assigning the nomenclature or while performing the nomenclature of the any organic compound by the IUPAC system of the nomenclature, first of all identify the functional group in that compound. This will is in deciding the terminus carbon atom. So that's why in this compound, that is, you will see that is how many functional groups are there. If you will see, that is, the first functional group is the carboxylic acid. The second, here there is a chloro, and here one is a cyano. And so that's why, but here you will see that is, they are the two functional group. One is the carboxylic acid here, and one is cyano. These two contains the carbon atom, but in the priority order of the functional groups, the carboxylic groups comes first. So that's why we will have to consider the carbon atom of the carboxylic acid as the terminal carbon atom, and we will have to start the numbering from the carbon atom of the carboxylic functionality. So we will have to start the numbering from the COOH, and while if we will select the longest chain, that will cover the maximum number of the substituents, maximum number of the unsaturation, maximum number of the substitutions, then this is the 8 member ring. That is, this is this. Since this is the 8 member, so that's why this root word will be the oct. Now come to the primary suffix. Again, the primary suffix is represents the saturation or the unsaturation in the compound. In this compound, at the fourth position, that is, there is a double bond. So that's why the 4 in is the primary suffix. The secondary suffix, the secondary suffix represents the functional group, but here there are the three functionality, and that is in the priority order. That is in the priority order, the COH comes first, so that's why we will have to consider the carboxylic acid as the functional group, and while the CN and the chloro group will be considered as a substitution. So that's why the 1-oic acid is the secondary suffix. Now come to the primary prefix. The primary prefix tells about the branching or the extent of the branching. That is, if you will see here, that is a branching, that is one here one methyl group and one propane group is here, but it is an isopropyl group. Okay, because at the second position, because the secondary carbon atom or the second number of the carbon atom in the propyl group is attached to the main carbon chain, so that is this one, there is the propane 2-al, or you can say that is the isopropyl alkyl group is attached to this one at the sixth position. But we while numbering this, that is we will have to give the again this assign numbering in this side chain, and at the second position, okay, the propane group is attached, so that's why propane 2-al. That's mean at the second position this carbon chain is attached to the main carbon chain, so that's why this is the extent of the branching. So that is at the sixth position the isopropyl group or the propane group is attached at the second carbon by the second carbon to the main carbon chain of the compound, and the 1-methyl group is attached at the seventh position. If you will okay, and if you will consider, and if you will see the you will see arrange the alphabetical order, the methyl and the propane group, then the methyl comes first, so that's why 7-methyl 6-propane 2-al will be the primary prefix. And now come to the secondary prefix. In the secondary prefix, that is there are the two substitution, one is a chloro at the second position and the cyano group is attached at the third position. Okay, since while arrange these two substitution alphabetical order, then the chloro comes first and the cyano comes later, so that's why 2-chloro 3-cyano will be the secondary prefix. So name of this compound is the 2-chloro 3-cyano 7-methyl 6-propane 2-al oct 4-in-1-oic acid. Now that is next one. In case of the esters, the alkyl group attached to oxygen or the alcohol group of the alcoholic counterpart is treated as a substituents and denoted by the prefix, and the carboxylic acid counterpart is treated as a main function group and denoted as a suffix. Now see the example. In this example, you see that is there is an anhydride group is present, COO. If you will see that is this can be broken in two parts. That is, it is the alcoholic counterpart, that is alkyl group, and this is the carboxylic acid counterpart. Okay, so because that is there the CO group is attached here, and it is this functionality is the acid group, because sorry, anhydride group. Anhydride is the anhydride of the acid and the alcohol. Now how to perform the nomenclature of this compound? Since as per this rule, we will have to consider the alcoholic counterpart or the alkyl group which is involved in the alcohol is treated as the substituent, and the alkyl group which is involved in the carboxylic acid counterpart will be treated as the functional group. So that's why if you will see that is first of all that is a O8. O8 is the suffix which is represented for the acidic anhydride. In this, the first of all the prefix will be used for the alcoholic counterpart. So that the alcoholic counterpart is here the ethyl. So that's a ethyl O8. Now in O8 and the between the ethyl, we will have to perform the nomenclature for the carboxylic acid counterpart. Now means that is we will have to perform the nomenclature of this part only, because ethyl O8. So now that soon is when you will perform the nomenclature of this compound, we will have to start the numbering from here, because the simple fundamental in this is kindly consider the CO as a COH group. Then you will have to start the number from here. So that's why, and the longest chain will be the 7 membered. So that's why the root word will be the hep. Since at the third position there is a double bond, so that's why is 3 in, because in the suffix, that is it is starts from the OH, so that's why we will have to remove the last E of the in. So that's why this is the have 3 in OH, that is this is the 3 in is the primary suffix and OH is the secondary suffix. Now come to the prefixes. That from the primary prefix will be for the branching. So here that is you will see that is one methyl group at the 6th position, and the 5th position there is cyclopentenyl group. So that's why the 5 cyclopentenyl and the 6 methyl. Okay, so that's a MnOP. So that is a 5 cyclopentenyl and the 6 methyl, and at the second position that is there is a amino group. So that's why ethyl 2 amino 5 cyclopentyl 6 methyl have 3 inoate will be the name of this compound. Now come to the another example. The another example, in this examples you will see also here that is there is a COO group. So that is this is the, and this represents a anhydride, and when that is this represents the anhydride, so that's why definitely it will have the two parts. One is the alcoholic part and another one is the acidic part. So that's why this is the alcoholic part and this is the carboxylic acid part. So first of all, that is the OH. OH means that is it is a suffix for the anhydride. And what is the alcoholic part here? The alcoholic part is here like this one. So from you will have to separately consider the alcoholic part and the acid part. In the alcoholic part, you are watching that there are the two functional group. One is the NH2 and the Cl. So that's why you will have to start the numbering from here. 1, 2, prime 3. Here you are seeing that's why we are considering the main chain. It is a main chain. Main chain will be considered for that skeleton that is involved in the carboxylic acid group, and whereas we will have to consider it as an extension. Okay, so that's why we have given the name prime. We have numbered the 1 prime, 2 prime, 3 prime in the alcoholic part. So that's why you will see that is there is a 1 amino, so till here, that is this is the alcoholic part, and since this is a substituent, so that's why it is used as the secondary prefix. So yes, that's why here the 1 amino, the 1 prime chloro propane 2 vial, since at the second position that is it is attached to the anhydride functionality. And what is the longest chain? Now that's will come to the carboxylic acid part. You will have to start the numbering from the carbon of the carboxylic acid. So that's why, and while selecting the longest chain, it is the 8 membered long chain. So that's why it is the oct will be the root word, and this is, and at the 5th position there is the in, that is there is the unsaturation. So that's why oct 5 in O8. Okay, so that's why oct will be the root word, 5 in will be the primary suffix, and OH will be the secondary suffix that is used for the anhydride. Now come to the part what will be the primary prefix. The primary prefix represents the functional group or the extension of branching. So that's why there is a no extension of the branching. There are the another functional groups are attached. One is the amino, chloro, and that is cyano, and one phenyl group is attached. Or you have to consider, that is you have to arrange them all in the alphabetical order. Then this will come as the 2 amino, 4 chloro, 5 cyano, 7 phenyl, oct 5 inoate. So that's why the name of this compound will be the 5 prime amino, 1 prime amino, 1 prime chloro propane, 2 aryl, 2 amino, 4 chloro, 5 cyano, 7 phenyl, oct 5 inoate. Now come to the another rule. In case of the ketones, if no any group of the higher priority in present in the main chain, The numbering of the main chain should begin in such a way that the carbonyl carbon atom comes at the lower position, because in the ketone groups we will have to assign the numbering to the carbon skeleton in such a way that the carbon of the carbonyl group should be assigned the lower position. See the example here. In this example, you are saying that is there is a keto group. One chain is here and one alkyl group is here. But you will see that is, if you will start the numbering from this terminus, or this terminus, then the position of the carbonyl group is higher than if the numbering is started from this terminus. So that's why we will have to start the numbering from this terminal carbon atom. So that's why the carbon atom of the carbonyl group can be assigned the lower position. And while following the longest chain rule, the root word will be the heft, since the longest chain rule covers the 7 carbon atom, or we can say it is a 7 carbon atom carbon skeleton. And at the thing now that this is the heft. Heft will be the root word, or it will be the root. At the fourth position, the compound is represent the fourth position. There is an unsaturation which is represented by the 1 double bond. So that's why the 4-in will be the primary suffix. And at the third position, there is the keto group is present. So that's why 3-on will be the secondary suffix. Now come to the prefix. At the prefix, you will see at the 6th position there are the 2 methyl groups. So that's why 6,6 dimethyl. So IUPAC name of this compound will be the IUPAC name of this compound is 6,6 dimethyl heft 4-in 3-on. Come to the another example. In this example, you are watching here, that is, there are the how many, first of all, as per the rule, first of all, select out the functional group of the higher priority order. Here, how many functional groups may be there? One is the sulfonic acid, chloro, amino, and carbonyl. Among these functional groups, the sulfonic acid SO3H comes at the top position. So that's why we will have to start the numbering of the carbon chain from the carbon atom which is adjacent to the sulfonic acid functionality. So that's why we will have to start the numbering of the carbon chain from this carbon atom. And as per the longest chain rule, we will have to select the longest chain which will have the highest number of the carbon atom, highest number of the saturation, highest number of the functional group, highest number of the substitution, or the highest number of the extension of the branching. If we will apply the same rule, then the longest chain is the 8-membered carbon skeleton. So that's why oct is the root. Now come to the primary suffix. Primary suffix is represented by the double bond or the triple bond, that is the unsaturation. At the 4th position, you will see that is there is a double bond. So that's why the 4-in is the primary suffix, and the primary and the secondary suffix is represented by the function group which comes at the top position in the priority order among the function groups which are present in the carbon skeleton, or the carbon or the compound which is taken into consideration. So that's why the CO3 as sulfonic acid functionality is the function group here which comes in the top in the priority table. So that's why 1 sulfonic acid is the secondary suffix. Now come to the primary prefix. The primary prefix is represented by the extension of the branching or the substitution. So that's why 8CH3 group is attached here, and the 3 so that's why this one is the 3-methyl group is extension, and whereas a 6-oxo it is also substitution, so that's a 3-methyl 6-oxo it is the primary prefix, and whereas a 2-amino 1-chloro 7-cyclopentenyl, okay, these all are the, these will be the secondary prefix. Now come to the next rule. If the same type of the functional group with the carbon atom like COH, CH, CHO, etc. are found in the organic compound, then the carbon atom of the function group is not counted in the numbering, and before the suffix to be used for the function group, numerical suffix namely di, tri, tetra, etc. are added. See the example here. In this compound you are watching, that is there are the 3 carboxylic groups. These 3 carboxylic groups are attached consequently on the carbon atoms which are just present in the neighborhood of each other. So that's why we will not consider this as the 5-membered carbon skeleton, as we will, if we apply the longest chain rule, we will consider this as the propane, as the root word, and propane 1,2,3 tricarboxylic acid, as if the same number of the if the same functionality is present in the that compound at about the 2 or the 3 times to the adjacent carbon atom. Similarly, see here, here the carbonitrile group is present at the propane, okay, to the, and it is attached to all the neighboring carbon atoms. So that's why this compound is the propane 1,2,3 tricarbonitrile. See here in this compound, that is, this is the CHO group, aldehyde group is present 3 times, and it is the, we will consider the butane as a root. So butane 1,2,4 tricarboaldehyde. The such a system of the nomenclature is also followed when the functional groups containing carbon atom is directly attached to the cyclic root, as per the that rule that we were discussed in the previous slide, or we can say that is we have discussed in the rule number 11. See the example here. For example, here it is a cyclic it is a cyclic root, cyclopentane, and the aldehyde group is attached to this one, so it is a cyclopentane carbaldehyde. It is a carbonitrile and it is attached to the cyclopropane, so it is a cyclopropane carbonitrile. Here that is 2 carbaldehyde moieties, and since the aldehyde groups comes at the para position to the hydroxy group in the pyrite order, so that's why it is a 2 hydroxy cycloheptane 1,4 dicarbaldehyde, because we will have to start the numbering from this functionality. Here 3 aldehyde groups are attached to the benzene ring, so that's why it is the benzene 1,2,3 tricarbaldehyde. Here 2 carbonitrile groups and the 1 amino groups are attached to the benzene, so that's why benzene is the root here, and the 1,2 dicarbonitrile and 3 amino will be treated as a substitution. So 3 amino benzene 1,2 dicarbonitrile and it is an ester, and here since this is ester, so that is it is a carboxylate. It is a alcoholic counterpart, methyl is the alcoholic counterpart, so that's why the methyl will be treated as a substitution, and this part will be considered as the counterpart of the functional group, so it will be considered as a primary prefix. So primary prefix, so cyclohexane carboxylate, so that is, it is a it is a methyl cyclocarboxane carboxylate will be the name of this compound. These were the general rules which are followed for the nomenclature of the organic compounds using the IUPAC system of the nomenclature. After joining this lecture and solving the problems given in different textbooks of organic chemistry, hopefully all the students are familiar with different general rules followed for the IUPAC nomenclature of the organic compounds. In the next coming lecture session, we will discuss about the IUPAC nomenclature of the alicyclic compounds, bicyclo compounds, fused compounds, and the spiro compounds. I, Shiv Kumar, is now signing off, and hopefully you have enjoyed this lecture session, and thanks a lot for joining me.